Welcome to Cheshire, England, home of the famous Jodrell Bank Observatory with its iconic Lovell Radio Telescope. This massive dish is the third largest steerable radio telescope in the world and was the largest when it was built in 1957. This was just in time to allow the British to watch the launch of Sputnik 1, the first artificial satellite launched obviously by the Russians. We'll get up close and personal to this amazing telescope and visit the Jodrell Bank Discovery Center right after this. Stay tuned. Hey, hello, hi, and welcome to episode 9 of KPO's European Astronomy Tour. This will be an exciting episode where we'll visit the Jodrell Bank Observatory, home to the massive 250-foot Lovell Radio Telescope. The observatory was founded in 1945 by Sir Bernard Lovell, who was the leading radio astronomer at the University of Manchester. Lovell's interest was initially the study of cosmic rays. As with most scientists, he was supporting the war effort during World War II, and during his implementation of radar systems, he noticed background noise on his radars that he attributed to cosmic rays. Also early on, Lovell used the equipment to watch the radar echoes caused by the ionization trails of meteors as they burned up in the Earth's atmosphere. It was a coincidence that the first time that Lovell turned on the radar systems at Jodrell Bank in December of 1945, the Geminid meteor shower was active. Today, Jodrell Bank is focused on collecting and studying radio waves from the planets and stars. The Lovell Radio Telescope is obviously the largest radio telescope at Jodrell Bank, but there's two others. The Mark II, 125 feet across, put in operation in 1964, and a 42-foot dish used for the observation of pulsars. The Mark II is sometimes joined together with the Lovell dish to create an interferometer, a combination of radio telescopes that allowed more detailed observations of celestial targets. These two can also be combined with several other telescopes across the English countryside to form what is called the Merlin network. When networked, Merlin can image at the same resolution as the Hubble Space Telescope. Well, I think it's time to check out the Lovell telescope ourselves, and we'll take this adventure right after this. So here we are at the base of the amazing Lovell telescope. So how does this massive instrument work? The most striking feature of the Lovell telescope is the huge white dish that can be seen for many miles around. This dish is fashioned in the shape of a paraboloid, similar to mirrors on reflecting optical telescopes. The shape of the dish allows it to collect and focus incoming radio waves on the central collector sensor, mounted on the central tower, thereby amplifying the signal from distant radio sources. Then the signal is routed to sensitive amplifiers that are super-cooled to provide the clearest signal possible. Some amazing facts about the telescope that I found on the Jodrell Bank website. The entire structure, including the dish, weighs 3,200 tons. The bowl itself weighs 1,500 tons. As we said, the dish diameter is a whopping 250 feet across, with a surface area of over 10,700 square feet. When they need to paint it, it takes 1,400 gallons of white paint. So yes, that's one big dish. The telescope is steerable in two directions, altitude and azimuth. The azimuth is pointed by rotating the entire assembly on a circular track. The altitude is moved with huge gear assemblies taken from large gun pointing mechanisms from two British battleships. 50 horsepower electric motors drives both of these motions. The telescope axes can be driven independently at high speed at a rate of 15 degrees per minute, which is actually pretty fast. The slow speed is actually sidereal rate, which counteracts the rotation of the Earth just like a clock drive does for an optical telescope. Another interesting fact is the telescope operators constantly monitor the weather, not rain or clouds, as these don't hinder radio astronomers as they do for their optical counterparts. Wind is the major concern. If the wind gets too high, when the dish is pointed in a more vertical position toward a target low on the horizon, there's a danger that it can be damaged. So when wind is a problem, the dish is positioned in a horizontal position, pointed at the zenith with the brakes locked in place. So now that we've seen Jodrell Bank from the ground, under the dishes, or bowls as they call them, let's get another more interesting perspective from the air. We'll fly high above Jodrell Bank right after this break. So let's have a look at the Lovell Telescope from the air, shall we? My wife was able to get us booked in a quaint little B&B right beside the observatory, as you can see. So this is a perfect location to launch my drone and get some aerial views. So enjoy these clips from my DJI Phantom 2 as it flies within a mile of the telescope. Well, I am once again definitely amazed and blown away by this amazing technology that we've seen in this episode of Jodrell Bank. I hope you've enjoyed the tour of the facility. You can see the episode notes at kpobservatory.org/EAT09, where you can find our itinerary and publication schedule for the rest of the trip. Throughout this tour, I'll be checking the site and YouTube for any comments or questions you may have, so feel free to ask away. Well, this wraps up KPO's European Astronomy Tour. I hope you've enjoyed this series. I know I've significantly narrowed down my bucket list of astronomical travels in the past 2 months. So next week, we're heading back to the US via the Queen Mary 2. I can't believe we're actually nearing the end of this fantastic adventure. Even now that we're completed the trip, I'll be checking the site and YouTube, as I said, for comments and questions that you might have. So happy travels and clear skies, and we'll see you next week when the regularly scheduled episode of Star Hopping returns.